but we have now, this is with this one, it's 2 sessions left of the AI crash course. So to just go through what will happen today is that we'll do a small checking just to follow up on the last. I've heard you mingling here, which is great, but we'll just do a small check-in to start off with, and then we'll talk a little bit about what happened last time, and then Elisa will take over and guide us through the world of machine learning and deep learning. So after this session, I'll know everyone here will be a lot wiser. Just as you've heard this before, but we really want to stress this, that this course is a collaboration between AI Sweden and Women in AI. Women in AI being a very, very interesting organization, global organization, really pushing and wanting to inspire more women to go into the field of AI for a number of reasons. Last week, we had the AI crash course, but we also had a really interesting why research event together with Hanan Salam, one of the founders, or the founder of Women in AI, and also Irina Risch, professor here at Mila, we're talking about continuously learning. So really join the community of Women in AI, but because there's both some really interesting and inspiring talks, but also opportunities within the field of AI, and it's really a vibrant community. And then we have AI Sweden, the neutral and national platform. There's the same thing there. There's a lot of events coming up, so do check ai.se for events even after the course, because now after these 5 sessions, you are more ready to go into the world of AI. You're more ready to go into the field of AI, and then definitely check out what type of opportunities and events are happening in this field. And just to take a bit of repetition before we go into do the check-in, because this is what I would like you to continue the dialogue today, and in the check-in, it's really about the quote from Ginny Robetti here that we talked about last time, that AI and being artificial intelligence, we've been talking about the definition of AI not being as good as we think. It was already a problem during the 1956 conference. So really to think about AI as augmented intelligence, to augment our own intelligence, and really enhance the things we're already really good at, or trying to find new patterns in data where we haven't found patterns before. So really think about artificial intelligence as a way to enhance human intelligence, a really strong toolbox, a really strong technology to do new things even better. So the check-in today is going to continue on this question. How would you like to augment your own intelligence? What would you like to be even better at in either your personal life or in the challenges or problems you're facing in your work or with your startup or anything? And then also share ideas. What would you like to solve with machine learning? We talked talked about some cases last time on real AI. So what would you like to solve? How could you use machine learning to do this? Because now we're getting even more in depth into the machine learning part, and I think having that in mind going into Elisa's session will definitely make it even more tangible and even more hands-on. So I'll send you out in breakout rooms, and we'll have 7 minutes, I think, in the breakout rooms before being back here and handing over to Elisa. So see you again here in 7 minutes. I will just resume the recording. So this is the 4th session now of the AI crash course. So last time we talked about real world AI, and now it's time to dig deeper into the world of machine learning and deep learning, getting a little bit more technical together with Elisa. And then next Wednesday on the 15th, we'll have a panel on the societal impact and the transformation with AI, and also dig a little bit deeper and open up for all potential questions or all questions of interest from you, but also from the panelists. But with that said, I would like to hand over to you, Elisa, to just take us in the world of the machine learning and deep learning, and also introduce you to the work you're doing as a PhD student at KTH, but also with your company where you're working with IoT and connectivity with robots. So I'm very excited to hear more about this.
Thank you for the introduction. Yes, so do I have the right to share my screen already, or? Yes, I see it. Okay, perfect. Then I'm gonna start sharing the screen and then we jump right into it. Yes. So yeah, hello everyone. It's very nice to see so many of you and hear like about your interest and like what you're working on and your passion related to AI. So for today, I prepare like an introduction to machine learning and deep learning. I try to keep it a bit like on a higher level, so that should be okay, like for beginners too, but hopefully you will gain something even if you had some experience on that. And I would like to encourage you to ask as many questions as you feel like. Don't be afraid of interrupting me, because I'm here just like for you to get some knowledge about that. So I would really like to open a conversation.
Yeah,
so,
I will help Elisa to take care of chat. If you have any question, please raise your hand. I think it's very good to present your question and elaborate on it. And Elisa, question to you: do you want to present in presenting mode, or is it okay for you? Because
yes,
we're seeing the whole presentation, the slides to the left too. Yeah.
I can switch to presenting mode right now. I might switch back like to move to the code later on, but that's good. Do you see the presenting mode right now?
Yes.
Great. Okay, then a little bit about me. I have a background in robotics and control theory. I'm originally from Italy and I moved to Sweden like 4 years ago. I've studied at KTH and now I'm starting a PhD like just 1 month ago on connected vehicles. And I'm also one of the founders of a startup called AB Connect, where we work to provide connectivity solution for like multi-device communication. So that's a little bit about me, like professionally. On my personal like free time, I really like these kinds of networking events. I'm really passionate about like trying to teach or like trying to get people passionate about technology and like trying to deliver that in a way that's not scary, because I feel a lot of people are scared about the technical part of it. Yes, so that's a bit about me and what to expect from today's presentation. So I will start with like a small introduction on what machine learning is and try to explain what's like the difference with deep learning and try to define a few terms that you might heard in the past or that you might end up meeting while you're like approaching this new field. I will mention a few different kinds of networks that might be interesting for some of your applications that you might want to look more into it after. I will specifically focus on the image classification task because I think it's a pretty simple example that many of us can relate with, and it's very good to just get started. And after that, I will go into the workshop mode while I have prepared a small coding exercise that we can do together. So it will be like live coding. I will share the template with you so you can code along if you feel like it, or otherwise just follow and do it. After we will share the solutions. Okay, so oh, I see now that's not, it's a bit not good resolution, but what is, so we have talked a lot about AI in these kinds of events. So what is like machine learning and what is deep learning then? So AI is usually, we had the definition right before from Peter, but what is the main difference between what is machine learning then? So I would say that machine learning is considered as a subset within AI, where you actually have a network taking care of solving a problem autonomously, where you're not delivering sort of algorithm to solve the problem, but you let the network itself learning how to approach the problem. And then if we go one step deeper into deep learning, that's when the network becomes deep, and which means you might have more layer, you might need more computational power to compute the results of your problem. And in these kinds of application, usually the difference is that in machine learning, you might have human intervention where you have, for example, defining features or things like this, while in deep learning, you let the network understand what features are important or not. But I will go more into details on this later. So why is it such an hot topic nowadays? So first of all, there's a lot of data availability in many different contexts, from medicine to autonomous vehicle, for example. There's a lot of data available, and there's a need of to use them to have a good outcome out of those. There's much more computational power compared to the previous years. And also we see from research and early industry application a lot of potential out of these kinds of algorithm. And I think probably in last sessions you had a lot of good examples of real life application there. But I just mentioned a few here, like from finance, medicine, automotive, and robotics, but also advertisement. That's something that's very close to us, but we might not think about it. And also art. I always find very interesting seeing like those kind of paintings that are not real painting, but they are generated by a network. So just added again a few specific examples. For example, like detection of bone fractures into medical images, or something that's called semantic segmentation, that is often used for autonomous driving. But if you see here, all the different cars that have their own square with their name, and that's the network understanding the difference between a car and a person, for example. And finally, I don't know if I can run the video, but I guess you see the image anyways. But this is something that I personally think it's very cool, and it's this changing sketch into photorealistic paint or like pictures. It's where a human person just draws different color on the side, and then the network just generates a masterpiece out of that. So this is a bit of examples and background just to give you inspiration and something to think about that perhaps might be interesting for your personal applications and study. Oops, I'm going a bit too fast now. Sorry.
We have a question in the chat.
Yes.
Emma, do you want to ask yourself?
Hi, yes, thank you. Yeah, I'm Emma, and I work at the Unicre Center for AI and Robotics. And so I wanted to ask, when you said earlier that a lot of data is available, and that's why there's a lot of focus on AI. I should also mention that I'm on the legal team, so focusing on human rights and personal data protection. So I was wondering, do you include like all the data, even personal photos and things that are potentially sensitive yet still technically on the public sphere? And then I had a follow-up question that more technical that I'm not aware of, but how easy is it to adapt that data to AI algorithms? Because that's another step, right?
Yeah, so I think when I say there is a lot of data available, I guess I meant there is a lot of capabilities to collect data potentially. And I think the personal or sensitive data, that's a very big topic. And for this, I can mainly talk about my experience in a lab where we work with autonomous vehicles and where we actually have vehicles that has camera on them. So we technically collect personal data. And the way we handle that is that we anonymize the person, like we have a kind of a segmentation algorithm that's similar to the one I showed before, where the person is identified. And before saving the data and storing the data, we just remove the face of the person. And that is just one possible way of doing that. But that's definitely something that's a lot like discussed, and people are looking for solution to make sure that the data that are stored and used for these kinds of application need to be anonymized or not. I mean, yeah, I'm not against of any human rights, but that's very good. I hope I answered. There was another part of the question, maybe.
Yeah, just how easily personal data can translate into AI algorithms. Because, well, you mentioned you collect the data yourself, so then you can kind of anonymize it yourself. I think I was focused more on content moderation or, personal photos on social media.
Yeah, I see. Yeah, I'm not sure like how. I think like for social media, usually you have how to say, you accept you set the privacy or your pictures in a way. So like the way these data are used, it's very I think it's a very good topic of conversation, how to make sure that you cannot, from the outcome of a network, get back and identify the people the people that have been used in a way like to generate those kind of network, if that makes sense. And that's a lot of research on privacy related to this. I think there's a group in KTH that work on it. So if you're interested, maybe I can point to the researchers that are working on that later on.
Sure, thank you. Yeah, you answered my questions.
Okay. Yes, so then I just jump into a bit of background here for machine learning. So usually when we think about machine learning, we think about different kinds or different families of algorithm, I should say. So you might have heard about supervised learning versus unsupervised learning, or something called reinforcement learning. So I just wanted to give you a bit of distinction between these three families to familiarize with. When we talk about supervised learning versus unsupervised learning, usually in the first one, you do have data that are labeled and you kind of guide in a way the network towards the goal you have in mind. In the second case, it's more you don't provide the network before the features that you would like to extract, but it's more up to the process to learn what to learn in a way. Finally, in reinforcement learning, that's usually a sort of agent-based simulation where you have a task and your agent needs to learn how to solve the task by trying it out and repeating it many times. So that's a little bit. If I should focusing a bit more, I think you might have heard, or that might be interesting for some of you, classification in general and the difference with regression. So classification is usually a task where you want to divide different two or more groups of data. For example, if we think about image classification, we will talk about later on, it could be cats versus dogs. So you have images of cats and images of dog, and you want your network to understand how to distinguish between the two types of animal. On the other hand, regression is more understanding the trend of your data. It could be like being able to make prediction by knowing how the data look like, being able to predict how a certain data point might look like. And then,
yeah, may I interrupt you for a
yes.
second? Because we got one more question about your previous discussion with Emma about the images and the security. And the question in chat is, Elsa, is your explanation only for Europe or the world?
Yeah, I mean, when I was talking about our lab, I was mainly talking about like Sweden and yeah, so Europe. I'm not an expert in data protection, so I'm not really sure like about how this is applied outside Europe in details. Maybe that's something Emma knows better from her legal background too. But yeah.
Yeah, it's probably even more data outside Europe because of, they don't have GDPR.
Yeah.
Mm.
I mean, even in Europe, it's highly contested because we do have the GDPR, but people are unsure of how to translate that into practice. So, I mean, right now, the leading document or draft document is the AI Act, but even that only has a self-assessment document that it would have the tech providers fill out themselves, and they aren't even, at the moment, aren't even required to send that to their clients. So this is still very much in debate, and currently it's in the hands of the tech providers to comply with data protection. But that's why it's in the news, because it's a lot of black boxes.
Yeah, I agree. It's an important question, and you, Emma, will have a lot to do. And many of us. So thank you. Back to you, Elisa.
Yes, no, but I love our from different backgrounds, and we like open up these kinds of discussion. Yes, so going back to the difference between machine learning and deep learning, as I started mentioning before, one of the main difference is on one side the depth of the network, meaning if this is the network with different nodes, usually in deep learning there are many layers more than what we have when we talk about machine learning. But not only that, especially the feature extraction, that's a task that's usually performed by human in the case of machine learning, but not in the case of deep learning, where that's part of the learning process inside the network. Yes, and then one step further, I mentioned the neural network, and we can imagine a neural network as like a set of neurons or a set of units that together form different layers. And how these different layers are connected with each other, it really depends on the kind of network you're working with. So in this case, we have like fully connected layers. So you see that if you look at this node, it's connected to each single one of the next nodes in the next layer. But that can vary from network to network. But one very important thing to just like keep in mind, especially if you want to build your own network, are like the input layer and the output layer. And for the input layer, that really is something that has to reflect the kind of data that you want to feed into the network. I'm going to give an example a bit more in detail later, but that's like something you have to tailor to your data as input. And then for the output layer, that's what you want to see. What do you want the network to give as output? Do you have, for example, 3 kinds of animals there, and you want to know which one of them it corresponds to image you're feeding in, for example, or what do you want from that? So that it's the output layer that gives you the answer to that. Yes. And then I've added 2 examples of networks that you might have heard of. First one is the convolutional neural network. And what I think it's special about this is the idea that from one layer to the other layer, you apply filters. And filters are just small matrices that you make them convolute through your image or to different layer, and you just it's kind of repackaging the content of your input image into something else that as human you might not really understand as much, but that is actually the process of learning. And in this case, if it's image classification, learning which kind of image that is. So that's just like a bit of overall idea into that. If we want to go in more details about that, I can try to go deeper, but it depends on, if you're interested in that. I'll just continue for now and then you let me know. But then another kinds of network that's very interesting as a concept is generative adversarial networks. You might have seen those images, like the faces that are generated by a network that look like real actors or real people, but they actually don't exist. It's just something that has been generated by a neural network. And the kind of network that does the job is something like this. And it's called a adversarial network, as you have 2 main components. One is a generator and one is a discriminator. The job of the generator is to create from random noise something that could be a fake image. And then you have a training set of real images of what you want to generate. In this case, they are numbers, but they could be faces of people or animals. And then you have another part of the network that is the discriminator. And what the discriminator does is trying to understand if the image you're feeding in, it's real from the training set, or if it's fake and it's generated by the generator. And it's trying to do this, and this is like a feedback loop where you back the answer of the discriminator and try to maximize the generator such that it keeps producing better and better images. And then when you obtain the performances you like, then you just use the generator part to actually generate your data. But yeah, this is that. Maybe stop for a second if there are other questions before going into the image classification task.
Yeah, I don't see any questions. Guys, you have a chance to unmute yourself and ask question.
I have a question.
Yeah.
Yes, earlier when you wrote feature, I don't know, feature creation or what you wrote, something. One feature is the same as a descriptor, is it?
Yeah.
And second, when you said that in neural networks you don't, the user does not. No, you said that the neural network generates himself, herself, itself. The features, I think you said. No, you say what did you say actually?
No, I meant, like, for example, in image classification, if you provide the different labels that it's available, or like you provide the different characteristics that are relevant. For example, if you know how many groups you have, or like if you know that you're like classifying between just two clusters of data, and you actually use, for example, like a state vector machine or something like that. But on the other side is when like you have, for example, you don't really provide the different characteristics that are needed, but you just feed in the data and you let the network encode into itself the way to differentiate between the different kinds of images. For example, if you have cats or dogs, and you just feed the data into the network, and then from the different layers, inside those layers, you will have features that are in a way encoded. For example, how the ears look like, or how the, I don't know, the face of the animal looks like, but you don't hard code those. You just let the network.
Yeah, later on, you never get to know about them, right? I mean, they are too complicated anyway to see.
Exactly. That you just let it do its magic in a way.
Yeah.
I hope that makes more sense now.
Okay, yeah.
Thank you for the question.
Yeah, we have one more question. Is from Anastasia. Do you want to answer it, ask it?
Yeah, hello. Thank you very much for the fantastic lecture. You mentioned 2 slides back. You can describe a little bit more about, yes, very interesting.
Yeah, so maybe I can take this at the end. I'll first talk about the image classification task,
of course.
and then I'll go a bit more in details into that, because you can use this to do image classification. And yeah, thank you for asking. Yeah, okay. But then I'm gonna talk a bit more about image classification, and perhaps this part might be a bit easy for some of you that maybe have experience or have worked with machine learning or like deep learning models before. But I just wanted to give like some visual representation and trying to explain the functioning of the process. Sorry. So what image classification is like pretty self-explanatory. It's the task of associating one image with a given label. For example, in this case, it's an image of a shirt, and you want the network to connect it to the word shirt. And this one is a shoe or a sneaker, and you want it to connect to the word sneaker. And by the way, you might recognize this data if you've done like some machine learning before or some deep learning before, and that's the fashionist dataset. Yeah, so this is the task itself, but how, wait, sorry, I'm jumping to a slide to another. Yeah, okay, but I'll just take it now then. The way we can solve this problem using neural network and how they work is like in a way mimicking the human brain, and that's, I think this slide was supposed to be way ahead than now, sorry for that. But I'll go to this part then, that's very important. So we want to solve this task of connecting one image to the correct label. So how do we teach the network how to do that? That is a process that we call training for the neural network. And the training, you can see it a little bit as when you study for a course and you use flashcard. So on one side you have an image, and on the other side you have the label. It might be you're learning a new language and you want to connect one word in your mother tongue into English, for example. And that's similar because you provide each data point of one image and its label. And then you want the network to learn a way to predict the label from looking at the image, only at the image itself. And how do you actually ensure that the learning is happening? You give a penalty or you give a score at the way the network is actually predicting. And then you change the network accordingly And then you repeat this process over and over and over until you have a network that's actually able to do the task it was supposed to perform. So 4 main steps. Get the data set, which most of the time it's one of the hardest tasks to do, and especially getting the label done. That's a huge work sometimes. You might have a lot of image samples, but you might be missing labels for that. And then you design a neural network on how to solve the task you want to, and then you keep on training it until the performance are like as you want them to be. And then finally, you can test them against, using a set that is not being used for the training part, so that you actually can say something about the performance and you don't risk to fall into, like, for example, things like overfitting. Overfitting is usually when you learn the data so well that you're not actually learning how to predict, but you're actually learning by heart the data set. So for the neural network, we're gonna have into the workshop in a bit. As I said, you have different kinds of layers, and they will be fully connected layers, as you see here. Fully connected means that each one of the node from the previous layer is connected to each one of the upcoming ones. And so how does that work? You have an image that needs to be fed into the input layer. So the way we build the input layer is such that it can contain all the pixels from the input image. And then you just elaborate through the different hidden layers. And then you have output layer that could be, in this case, it's a shirt or it's a sneaker, if we have a data set of just these 2 kinds of images. And then imagine one first step of the training. We input this image, we let it predict. It predicts that's a shirt, but it's wrong. So we give the feedback automatically by comparing the label to the prediction of the network. And if that's wrong, we do the feedback back and we modify the network to improve. And then eventually, hopefully, it's gonna learn how to do the prediction correctly. And yes, so this is it for this part now. I'm gonna move into the workshop. So I think what I'm gonna do now, I'm gonna stop sharing for 1 second, and I'm gonna send the link or send the file for the empty document if any of you want to try and code along at the same time. I think I can share it in Zoom. I'm gonna try it out now in the chat. Okay, do you see the document now? Yes.
Yes.
Okay, great. So now I'm gonna share my screen again and show you. Yes. So I'm sharing my screen again. Perhaps before getting into this, if any of you might not be familiar with Google Colab, I see there is someone that has Anastasia.
Yeah, I cannot see the file in the chat, for example.
Yeah, I see it. It was sent to everyone. Can we do it? Yeah, thank you, Peter. Do you see it now, Anastasia?
No.
Maybe we can send it through email to her.
Yes, Anastasia, write your email there and I'll send it to you through through email.
Thank you. Okay, then I'm gonna start with this a bit slowly. So hopefully we'll catch up. So what you can do right now after you have the document downloaded is that you can take the document and actually just drag and drop into one folder into Google Drive. So from that, you should be able to open with Google Collaboratory. And if you don't see Google Collaboratory in your options here, you can choose Connect More Apps and look for it. And after that, it should work. Yes. Maybe I'm just gonna wait a second, and if you just can let me know if when you're done with this, if you want to try and code along with me, or otherwise I can just start writing the code and then share the final, the filled-in version afterwards.
Yeah, let's wait 1 minute and see
Yes.
how it's going.
And maybe while we are waiting for that, I can just say a few words related to the convolutional neural network, because I prepared a workshop for that too. I don't think I will have time to go through both, unfortunately, but I can share that with you. So if you're interested in looking into that, you can have an example as a starting point there. But the idea is to have filters or kernels that are small matrices, and you have them transition through all your image, and then that creates a different image or a different layer that's smaller than the one you had before, typically. And by repeating this process over and over, you obtain a result that's encoding features from the image itself, and you're able to make predictions. And it's a quite powerful tool. And if you're interested in like mathematics, or that's a lot of to look into that, and it could be quite interesting if that's something you're you would like to learn. Yes.
Yeah, we don't have any questions, or probably someone. Then we can continue.
Yes. So if everyone is ready, I'll just getting started with this. So the aim of this is just to show you an example and just have an idea of how it looks like, and to actually write the code. So I've heard before that you have some people that have experience in Python, which is absolutely great. So maybe that will be a bit easier. If you don't worry about that. But the task we're gonna solve is a classification problem. And we are gonna use as data set something that's called NIST dataset. And before jumping into that, we need to import the dependencies. And the dependencies are all the library or any external libraries that you need into your code. And for this specific problem, we are going to import something that's called TensorFlow. And what TensorFlow is, it's an open source library that really helps you like in developing, gives you a lot of tools, so you don't have to implement everything by yourself when you're building machine learning models. And we are also going to use Keras, which is an interface that's built on top of TensorFlow, that's even like very powerful. And as you will see when we are going to use it in a bit, it gives us a lot of capabilities without having to write so much code. So I'm going to import Keras. That's from TensorFlow.keras import. And I'm going to import different things. I'm going to import first something that's called datasets. I'm going to import something that's called layers. And I'm going to import something that's called models. Now, this probably doesn't ring a bell at this phase if you haven't used this before. But these are all, built-in functions that we are going to use in a bit. And if you're starting with this and you want to know more, if you go to the TensorFlow website, they have a lot of amazing tutorials on how to use this. And also you can check on specific functions on how they work. And the more you use them, the more it gets easier. We're going to import something else. We're going to import something that's called matplotlib.pyplot. And this is for plotting, mainly for plotting. And then we're going to import NumPy too. Yes, NumPy as NP. So again, maybe I should have said this before, but if you haven't used Google Colab before, it's a little bit it's a notebook. So you see you have text here and you have cells that are called cells. The way you run this cell is either by pressing this. And
can you make the picture a little bit bigger?
Yes. Let me see. How can I do that? Does that look better now?
That looks better, yeah. Thanks.
Okay, great. Thank you for asking that. So either you can press on the arrow here, or you can press Control Enter, and then it's gonna run this cell. Okay, now that we have imported all these dependencies, we move to the next step. So we've seen before that the first step is actually getting the data set. So for us, we are going to get the data set from Keras directly. So to do that, I'm going to call this NIST. Yes. And I'm going to use this thing that we imported just now. That's called dataset. Datasets.NIST. And I'm going to run this cell. And here you see the red arrow. It means that's successful. Okay, so now we have our data set here in what we call the NIST. Now what we are going to do is we are going to divide this data set into different sets. So we need something to train the network in, and we need something that the network don't see, like for the performances later. So we're going to have a training set and a test set for this specific problem. So the way that I'm going to code this is I'm going to call train images and train labels, and then I'm gonna do the same thing with the test and just labels. And how I'm gonna do it is I'm gonna use the function that's built into the NIST dataset already from Keras. So I'm gonna use NIST.load data. You see that I get the suggestion here, and that is because it's a built-in function. Yes, and again, if it's the first time you're building a network, of course you don't know how this function works, so you've never used before, you don't think about it. And that's when I think the documentation into TensorFlow directly or Keras website is really great to get things started. And then we're gonna do another step, which is a little bit of preprocessing. This is a very important step, and usually it requires more than just what we're gonna do now. But just like to, as an example, and just to show that there is some pre-processing done, we're gonna do this. And that it will be quite simple. So I'm gonna call just the image part. So train image and test image. It's equal to the train images that we had before. And I'm just going to divide this by 255. And the reason that we do that is because we want our data being between 0 and 1. So in this way, we obtain that because before it was until 2. So we kind of normalize the data set in this way. Yes. I'm gonna do the same with test images. 55.0. Yes. So I'm gonna run this part and see if everything is okay. And we see that downloading and so everything is on track. So moving one step forward, I'm going to define the class name. So what is our dataset? Our dataset is the NIST dataset, and the NIST dataset consists of images that are numbers, are handwritten numbers. And what we want to do with this process is to guess the correct label, which is the real number there. So our class name, or our different classes that we want to predict from, it's gonna be numbers or digits between 0 to 3, 4, 5, 6, 7, 8, 9. I hope I didn't miss any digit, but it should be correct. And that's it. So what I would like to check at this point is that the dataset we loaded is actually of the expected shape, what we expect to be. So I'm gonna try to do train images dot shape. And let's see what we obtain there. Yes, so we have 60,000 images in this training set, and each single image is 28 times 28. And that's what we expected from knowing the data set there. Another good step is checking the length of the labels to see if we have a label for each training image. And that we do. So we can say that that's correct. Now, I'm not gonna do all the tests that I had in mind because for reason of time, but maybe I'll just do one final thing, that is plotting one of the images so that we all see how these images look like. So to plot them, I'm gonna use PLT, which is from Matplotlib we imported previously. I'm gonna just create a figure, and then plt.in show, and what we can show maybe the train images, yes, and I'm gonna select the first or second image. I'm just going to do a color bar here just to make the plot look nice, and then show. Okay, hopefully, yeah, okay. Yeah, so you see how one of the images look like. So that's one handwritten digit. We can just do, I don't know, fifth image to see how that looks like. And that's a 2, and so on. So there will be, or the whole data look something like this, where we have this handwritten digit, and some of them are pretty clear. The one we saw before, it was. This one could be even a 6. I mean, it can be confusing for humans though. Okay, but then we can consider the preprocessing phase and loading all the data done there. I'm gonna go directly to building the model now. So how do we build the model? So we have seen before in the presentation the different layers. Now it's not, yeah. We've seen the different layers. So the way we do, we build the model with TensorFlow and Keras is that we actually go and add each single layer one by one and specify which kind of layer we want in that case. Yes, so I'm gonna define something that's called model, and I'm gonna call models dot sequential. And now from here, we are gonna be adding all the different layers that we have seen before into the presentation. This is, yeah, that's the syntax we have. So we have first layers. I'm just gonna write directly. But for the layers, we're gonna use, we're gonna start, sorry, I'm just, yes. So we're gonna start using something that's called layers, which we imported previously from Keras. So layers dot flatten, we're gonna use this kinds of layer as input, and we want to specify the input shape. And does anyone remember what was the shape of the images that we've seen before? I'm tricking people. But if not, I'm just gonna go ahead with that. But it was a 28 times 28 image. So we specified this, and then yes, and then I should go on another here. So then we do another layer. I'm sorry, it opens up the suggestion so you cannot see. But the second layer we are going to use is the dance layer. As I said, like we have the fully connected layer at this point. And in this case, we're going to specify 128, and we're also going to specify the activation function. The activation function is something I haven't talked about previously in the introduction, but that's basically sorry, what we use to actually get the network to actually learn and do something about it. So for these problems, we're gonna use an activation function that's called relo. Yes. And then we're gonna move forward. We're gonna add one layer that's called dropout. This layer, it's usually added in to make sure that we are not doing overfitting. The way this layer works is that we're going to specify a rate here. That's, in this case, I chose 0.2. But the way that this works, that while you're training, you'll be like discarding like some values and putting them to 0 in a not random way, but like with this kind of rate. And the reason why we do that, you want to just mix things up a bit more on an intuition level, to in a way that you don't learn too much by heart the data set you have. But this will not be used when you actually go and use the model to do your own prediction. Yes, and then I'm going to add one final layer. That's the dance layer again. And dance layer here, how many nodes do we need? So if you remember from before, we do need as many as the number of outputs that we have. And in this case, we have 10 digits that we might want to predict. So we are going to have 10 here. So we have created the old network. One useful command that I suggest you to always use is model.summary. And I'm just going to run this so you see how that looks like. This is, to me, it's always very, very useful, especially like with a convolutional neural network when you want to really check that the dimensions make sense. But that's a way to check your network, how it looks like, and yeah, to make sure that you built what you intended to. So that's that. And then we move. Oh, yeah. Okay. So we move to the next step. Now we have created the model, but we haven't compiled the model yet. So we just like created a structure that looked like that, as we described before. But we need to compile it, specify optimization, and specify what before I called penalty score in case your prediction is not correct. So I'm gonna do this. I'm gonna use model, that's the one we defined previously, and I'm gonna use the command .compile. And yeah, I will use an optimizer that's called Adam. And I mean, like in this, I've added a bit of more explanation here and links if you want to yeah, learn more about the different kinds of optimizers. I'm not gonna talk about that now because I see I'm running out of time. I'm just trying to finish the network here so you can see it running. I'm gonna add the loss function, and I'm gonna use from Keras, I did not include that. So I'm gonna use from Keras losses, something that's called sparse categorical cross entropy. And I'm gonna just specify this from Robotics. Yeah. And I think just last thing, we want to specify the metrics. And for this case, we want to see the accuracy. And that's a little bit about asking a feedback on how the network is learning or is performing throughout the process. So I'm gonna run this. Hopefully, yeah, I didn't make any mistake. Now, the not final, but one of the most important steps is to actually start the training, because we just created the whole structure, but now we need it to learn. So to do that, we use a command that's called fit. I'm gonna use model.fit, and I need to fit in the data. So we defined train images, and then I'm gonna fit in train labels too. And I need to specify or I can specify the number of epochs, how many times I wanted to repeat the data or study the flashcard before actually, yeah, it's done. Then I'm gonna add 5 epochs. I'm gonna run this now. This might take a bit. And then you can see here that the learning process started. We can see the loss and we can see the accuracy of the network. So we see that we start already from like 91% of accuracy. But
Hey, can you
yeah.
please a little bit up in previous cell with code?
Yes. Is
Thank
this okay?
Yes.
Yeah. I'm sorry if I'm going a bit fast. Good. Then I'm just gonna, yes, wait. Yes, so now we have both cells that are visible, but we can see that you have finished our training. We have reached epoch 5, and we see an accuracy on the training side. That's 97%, something like that. What we can do right now, is it okay if I move down?
Yes.
Okay, thanks. Gonna put right here. So, I mean, now we have printed everything, so we see this. But in case we want to, yeah, to do an evaluation of the model and like print these results separately, we can do test, loss, and test. Sorry. Here, this is the accuracy and loss that's computed on the training set. So you see I'm feeding in the training and the training images and training labels. Now I want to see how our data set, our network performs when we feed in data that has not been seen before. So I'm gonna do accuracy. And I'm going to use a new command that's called model.evaluate. And to evaluate, I'm going to feed in test images, test labels, and I'm just going to put purpose equals to 2 because I want to see what's happening. And yes, so we see here different values, and that's what we expect when evaluating on a set that's not been used for the training part. But we see that the accuracy is not so far away from what we have previously. Now I see that we are running out of time again. So I think I'm gonna stop here. I'm just gonna mention briefly what I had before. So now here we are trying to make a prediction whether it's one image or another kinds of image. But what is usually very interesting is seeing the percentage of how confident is the network in predicting that's the image corresponds to one label compared to the other. So that's a little bit what I had in the rest of the script here. And I'm gonna share this, if that's okay. I'm gonna send it to Maria, I guess, if you can share it with the participants. And also the one on convolutional neural network. And so I hope that was useful. And if you have any questions, feel free to reach out to me or ask anything.
So we have a few minutes for questions now. I ask.
Yeah, I just wanted to thank you very much. You're a fantastic teacher. It's very wonderful, and I got a lot of information. So thank you a lot.
Thank you. I'm really glad that you find it useful.
And thank you so much, Elisa. It's wonderful. Do you have I'm just curious to see, for people that want to, or for the participants that wants to go even deeper in this, do you have any recommendations on what they should do, or where they could train?
Yes, that's a very, very good question. I'd say I would first recommend them to visit the TensorFlow website. They have amazing tutorials there. And if you want to start learning, that's very good. You can also look at PyTorch instead. I'm most familiar with TensorFlow, but that's an alternative to that. And I know that there are also very good courses in Coursera about deep learning, but perhaps that could be a bit more theoretical. I really think that by having a fun problem that you would like to solve and just looking for solutions online on how to solve it, that's probably the most fun approach, to me at least.
And just as you said, there's so much going on within image right now. I think we will talk, or I hope we'll talk next week also about multimodals or multimodality, where you have clip, for example, where you translate images to text and text to images and so on. So there's really a lot of things going on in this field right now. But Elisa, thank you so much for sharing. I just saw that there was some thank you, and if you have any more questions, please feel free to reach out to everything that's been going on in this field. And I also would like to know more about your startup next time as well, Elisa.
That would be nice.
So we will definitely have to talk more about that. For the course and all of your participants, next week will be the final session of the AI crash course. So that we will have a panel discussion and go in deeper in some of the questions that were here today regarding data privacy, regulations, because I know that there's a lot of both concern, but there's also a lot of questions, because as we know, we interpret and transfer GDPR in very different ways in Europe, but there's a big difference between how we tackle privacy in both, if we compare Asia, Europe, and North America as an example. And we also have some interesting regulatory talks with the EU right now. So there's a lot of things going on, and some of them we'll talk about next week. If you have any questions about the course, yeah, Elisa, if people want to reach out to you, where do they go and how do they reach you?
Yes, so you can reach out to me on LinkedIn. Maybe I can post the link there, but also on Slack. I am in the Women in AI Slack channel, so you can reach out through there or by email. It's ebin@kth.se.
Exactly, and that's why you need to be either in the Women in AI Slack, the community, or you'll join the Slack community through this QR code here. Join the AI crash course, but also make sure to look at all the other events that are going around and the interesting threads about job offers, about articles, about speaking opportunities. There's a lot of things going on. So thank you so much for today, for attending. Elisa, a big thank you to you. This was excellent, a very pedagogical way to explain this, because this is really hard. If you want to reach me, you can reach me on Twitter or on LinkedIn. Otherwise, I hope to see you next week as well for the last session of this course. And for those attending that one, there will be a diploma as well. So we'll send that out later afterwards. So thank you so much, guys, for attending today, and I hope to see you next Wednesday.
Thank you. Bye-bye.
Thank you very much, Elisa. It was a great presentation. Great class.
Thank you.
And thank you, Peter and Mark.